Newton's laws of motion. Background. Sir Isaac Newton, 1643 to 1727, an English scientist and mathematician famous for his discovery of the law of gravity, also discovered the three laws of motion. He published them in his book Philosophiae Naturalis Principia Mathematica, Mathematic Principles of Natural Philosophy, in 1687. Today these laws are known as Newton's laws of motion and describe the motion of all objects on the scale we experience in our everyday lives. Newton's laws of motion. First law, an object at rest stays at rest, or an object in motion stays in motion, in the same direction / at the same speed, unless acted upon by an unbalanced force. Also called the law of inertia. The tendency of an object to resist any change in its motion. Inertia. A property of matter. The tendency of an object to resist any change in its motion. The greater the mass, the greater the inertia. The greater the speed, the greater the inertia. Examples of Newton's first law. A car suddenly stops and you strain against the seat belt. B. When riding a horse, the horse suddenly stops and you fly over its head. C. The magician pulls the tablecloth out from under a table full of dishes. D. The difficulty of pushing a dead car. E. Lawn bowling on a cut and rolled lawn versus an uncut lawn appear. F. Car turns left and you to slide to the right. Examples of Newton's first law. Newton's first law. Newton's first law of motion. An object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by a net force. Newton's first law. Newton's first law of motion. Inertia. Law of inertia. Inertia. Tendency of an object to resist any change in its motion. Increases as mass increases. Some examples from real life. A soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. Two teams are playing tug of war. They are both exerting equal force on the rope in opposite directions. This balanced force results in no change of motion. More examples from real life. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia and it takes a large force to change the motion. Once they are moving, it takes a large force to stop them. On your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia and exerts a very small force on your car, so small that you don't even feel it. If objects in motion tend to stay in motion, why don't moving objects keep moving forever? Things don't keep moving forever because there is almost always an unbalanced force acting upon it. A book sliding across a table slows down and stops because of the force of friction. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. Newton's first law. An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. What does this mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. Newton's laws of motion. Second law, the greater the force applied to an object, the more the object will accelerate. It takes more force to accelerate an object with a lot of mass than to accelerate something with very little mass. The player in black had more acceleration, thus he hit with a great amount of force. Newton's laws of motion. Second law. The greater the force, the greater the acceleration. The greater the mass, the greater the force needed for the same acceleration. Calculated by F equals ma. F equals force, m equals mass, a equals acceleration. Examples of Newton's second law. A. Hitting a baseball, the harder the hit, the faster the ball goes. B. Accelerating or decelerating a car. C. The positioning of football players, massive players on the line with lighter, faster to accelerate, players in the backfield. D. A loaded versus an unloaded truck. Examples of Newton's second law. F equals ma. Newton's second law of motion. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. F equals ma. Force equals mass times acceleration. Newton's second law. Force equals mass times acceleration. F equals ma. Acceleration, a measurement of how quickly an object is changing speed. Concept test: is the following statement true or false? An astronaut has less mass on the moon since the moon exerts a weaker gravitational force. False. Mass does not depend on gravity, weight does. The astronaut has less weight on the moon. Newton's laws of motion. Third law: for every action force, there is an equal and opposite reaction force. Forces are always bad. Examples of Newton's third law. Rockets leaving Earth. Guns being fired. C. Two cars hit head-on. D. Astronauts in space. E. Pool or billiards. F. Jumping out of a boat onto the dock. G. Sprinklers rotating. Examples of Newton's third law. Newton's third law: for every action, there is an equal and opposite reaction. When you fire a gun, you feel the recoil. Some of the funniest things in cartoons follow physics that have been exaggerated or just plain ignored. While Coyote hangs suspended in space over the canyon for a lot longer than an object would in reality, but it is the anticipation of the drop and Wile's facial recognition of the upcoming pain that is so classically cartoony. So some laws are stretched for comical effect. Examples of Newton's third law. Newton's third law of motion. When one object exerts a force on a second object, the second object exerts an equal but opposite force on the first. Newton's third law problem. How can a horse pull a cart if the cart is pulling back on the horse with an equal but opposite force? Aren't these balanced forces resulting in no acceleration? No. Newton's third law explanation. Forces are equal and opposite but act on different objects. They are not balanced forces. The movement of the horse depends on the forces acting on the horse. Newton's third law: action-reaction pairs. The hammer exerts a force on the nail to the right. The nail exerts an equal but opposite force on the hammer to the left. Newton's third law: action-reaction pairs. Field goal FR. The rocket exerts a downward force on the exhaust gases. The gases exert an equal but opposite upward force on the rocket. Field goal FR. For every action there is an equal and opposite reaction. Newton's third law. For every action there is an equal and opposite reaction. What does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. There is a balanced force acting on you: gravity pulling down, your seat pushing up. Think about it. What happens if you are standing on a skateboard or a slippery floor and push against a wall? You slide in the opposite direction, away from the wall, because you pushed on the wall but the wall pushed back on you with equal and opposite force. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe hurts. Review Newton's first law. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless acted upon by an unbalanced force. Newton's second law. Force equals mass times acceleration, F equals ma. Newton's third law. For every action there is an equal and opposite reaction. Newton's laws of motion. An object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Force equals mass times acceleration, F equals ma. For every action there is an equal and opposite reaction. Which of Newton's laws of motion apply to these situations? An object rests in your hand. A ball is tossed into the air. A car windshield hits a bug. A person sits on a table. A person jumps up from the floor. A baseball bat hits a baseball. A truck and car hit head-on. Any others? http://smartread. Olamis. http://nmgk8/curriculum/middle school/8/discovering_laws/discovering%20 newtons%20 laws.ppt http://www.3.science.camu.edu/cmse/powerpoint/newtonslaws.pptv